Good morning, Camille. Good morning, Arina.
Okay, Lourdes, get ready for today, please.
Okay, guys, good morning. The class going to be the start right now. So just enjoy the class and remember, if you have some question, you can turn your microphone or you can send your question or you consult by chat and the teacher going to be respond you, okay? Okay, Naya, the class is due. Just start.
Okay, thank you. Good morning to all. Okay, today we will discuss about the scope of chemistry and the background or history of the chemistry, from where the disciplines of the chemistry came. So, first of all, we will discuss what is chemistry and what we study in chemistry. Generally, when we discuss its definition, it is simply chemistry is a sub-discipline of sciences. As we studied in the last lecture, we studied that how we conduct an experimental approach, or how we solve a problem with the help of biological method or scientific method. So the scientific method is applied in all of the field of sciences. We study physics, chemistry, biology, or other disciplines. We always prefer to scientific method to study all the process that we study in our criteria. So chemistry is a sub-discipline of sciences and that deals with the study of matter. So simply we can say that chemistry is a study of matter. So from matter to a higher level, we study all the things such as molecules, carbohydrate, and other things that does not come into the study of chemistry, because study of chemistry only discuss the atomic structures of the compound or anything that we consider. So the study of matter is basically called as chemistry, and the substance that constitute it. So matter is a substance that is formed of some smaller substance, and it is also deal with the properties of these substance and the reaction undergone by them for the formation of new substance. So basically chemistry is a study of matter that deal with the substance and their properties and the reaction that is occurred between them, and which new substance are formed, that all deal in the study of chemistry. So primarily focus of chemistry is on atom, ions, and the molecules, which in turn make up the element and compound. So the basic form we discuss in chemistry is only that is element, and element join to form a compound, and we that is we already know, and we will discuss in another lecture also. So it is a general introductions about the chemistry, and this is the more information about it, and the specified definition of chemistry is here. So these chemical species tend to interact with each other. So these chemical species are these that may be atom, it can be ions, or it may be a molecule, or it may be an element. So these chemical species tend to interact with each other through a chemical bond, and the chemical bond may be of 3 to 4 type, that is studied as a covalent bond, hydrogen bond, and ionic bond. These all are chemical interactions. So it is important to note that the interactions between the matter and energy are also studied in the field of chemistry. So we studied thermodynamics. There we will discuss about how matter is changed into energy and energy is changes into the matter. So this is basically another definition of first law of thermodynamics, that energy cannot be created and destroyed. And so these chemical species tend to interact with each other through a chemical bond, and a chemical bond exists in the form of energy. So it is important to note that these interactions are basically a chemical bond, and between two substances, one is matter and the other is energy. So matter converted into energy and energy converted into matter. These are also studied in the field of chemistry. The study of element and the compounds, their properties. This is the basic and specified definition of chemistry. So the study of element and compounds, their properties, composition, and the structures, as well as how they can change, and the energy that is released or absorbed during such changes, is the subject of matter, is of the science known as chemistry. So these all are the maybe a content of, that is basically discussed in the field of chemistry. These are the some uses of daily lives. These are the uses of chemistry in our daily life. There may be most, but we will discuss simply because we are discussing only some uses, because we are at the basic level. So the process of photosynthesis, we know that the photosynthesis process occur by the light that is in the form of energy, and the energy is used to convert a carbon dioxide and water molecule into a molecule of glucose. So this is the light energy reaction and the matter interaction. So the process of photosynthesis that enables the plant to convert water, sunlight, and carbon dioxide into glucose and oxygen is a chemical reaction. So these chemical reactions are basically discussed in the field of chemistry. So this process is the foundation upon which entire food chain is built. So this is the one of the daily life use of chemistry in our routine. Soaps and detergents that are used for hygiene's work, such as use as chemical process known as emulsification. And emulsification basically is done by the lipids molecule, and furthermore they are produced using a chemical process known as a sponification. So this is a complete chapter, sponification and emulsification. That is basically discussed in the carboxyl or carboxylations of the organic chemistry. So we will discuss completely it there. So this is a simply use of chemistry or chemical reaction in the formation of soaps and detergents that are used in our daily life. This is the third use of use in our daily life of the chemistry. Even the sunscreen used by a human to protect themselves from the harmful UVA and UVB radiations of the sun is based on the chemistry. These lotions and creams consist of, this is the medicinal chemistry. These lotions and creams consist of combination of inorganic and organic compounds that either filter or block the incoming ultraviolet radiations to protect the skin from the ozone or UVA lights. We apply different types of creams or lotions on our body. So these cream and lotions are basically formed by the different chemical substance or different chemical reactions, and such as sunlight screens that protect our eyes from the UV radiations. Also discussing the field of chemistry. So now we will study the basic sorry, basic history of chemistry. Where did it all begin? Where the chemistry has started? It is started in the early start of 1,000 BC, the production of iron from ores. And this is also a complete chapter that is basically studied as purifications and uh, uh, purifications of different materials such as gold, silver, iron, and we purify these all metals from their ore to their pure forms. Wine making, primitive alloys, that is basically a combination of one or more than two metals, that is called as alloy. And farming, that is fertilizers, that is urea, and there are many fertilizers that are basically a primitive form of chemistry that were formed by the chemical reactions and purifications method. So the study of chemistry begins in the early 1000 BCs, and that is started from the purification or production of iron from the ore. So the early elements in 340 BC, Aristotle proposed that all matter was made up of composed of earth, wind, fire, and matter. So this is just a perceptions that is formed by the Aristotle. The earth or maybe the matter consists of only four things, that is wind, fire, water, and the earth metals. And then came the idea of alchemy, and they are also called as alchemists. This era started from 1500s to 1700s, and this is the trial and error method and serendipity. There are big claims by the alchemies and a little returns, that is gold universal solvent, because they basically use gold, and that's why they are called as alchemy, and they use gold as a solvent substance and produce gold from different substance. Discovered distillations and recrystallizations, because basically this era is basically describe or use these process to purify ores, chemicals, or metals from ore forms. So this is called as alchemy era. 14 basic elements that didn't known what elements were, that are sulfur, mercury, carbon, iron, plutonium, copper, tin. These are the elements that are basically purified or used in this era only, that is started in the 1500 and ended in the 1700. So this is the era of alchemy, and they use different elements for the distillation and recrystallization process, and the gold was used as a solvent. So there is a question, how would you go about the making purifying element? How element can be purified? There are three methods that can be used to purify an element, compound, or anything that is made up of chemicals. The first method that can be used as it is a sublimation. The other form is crystallization, and the other form is distillation. These are the three processes that can be distilled into details, but here we will discuss only about their names, because we are discussing just the background information, how the chemistry has begun. So this is the experimental method. Jean Baptiste and Wilhelm. This is a scientist who apply an experimental approach in the field of chemistry. As, as we studied in the biology, a scientific method we start from the observations, and then we conduct a hypothesis, and then we conduct a experimental on the basis of a hypothesis. So these scientists also apply the similar method in the field of chemistry for a chemical reactions. So here is simplest studies about his uh, approach. So you will be familiar with the experimental procedure involving forming a hypothesis, conducting an experiment, and the reviewing the results. So this is the same method that we discussed in the scientific method. Jan Baptist Van Helmont was the one of the first scientists to introduce the idea of carrying a chemical experiment. He measured weight and observation, observed a chemical and biological reactions. So this is he is the first scientist who conduct a chemical experiment in the lab. So he observed a chemical and biological reactions that are performed by the different elements. Van Helmont was the first scientist to think that the air might be worth studying, and he realized that there might be a more than one type of air. So he claimed that the air is a mixture of different substance, and we know that the air is a mixture of different gases, as air consists of oxygen, carbon dioxide, helium, nitrogen gas, sulfur dioxide. Different types of gases are can be the constant of air. So he studied his first experimental observation with the air, and he realized that the air is not singly one type. It may be more than one type. So he burnt charcoal, that is basically a carbon, and he burnt a charcoal and found that gas produced did not support the combustion. The gas basically was carbon dioxide, because when he burned a charcoal, it emit carbon dioxide, and that is not a supportive of combustion process. Fermentation produce the same gas, because we studied that the last product in the glycolysis, how the glycolysis occur, and the last product of the glycolysis in the absence or presence of oxygen. So the fermentation produced the same gases. He actually coined the word gas. When Helmont found that some metals could be dissolved in acid, and then the same mass of metal could be reclaimed from the solution. We know that if we dissolve some metals such as copper, silver, or some other metals in HCl or other acids, these can be dissolved in the liquid form in the acid, and the same amount of metal can be can be extracted from the solution. He was the first to use the boiling and freezing point of water as a standard for the temperature. So these all are the achievements of Baptist during this experiment. He used the boiling and freezing point of water as a standard form. These are the pretty amazing example of experiment for the scientist in an era still dominated by the Aristotle conclusion. So the last conclusion that was conducted by the Aristotle, matter is form of earth, wind, and fire and water. So that conclusion is experimentally solved by the Baptist Van Helmont. Then he said that all these things are from matter. So who is the father of modern chemistry? There are classical and a modern approach for every subject. that is studied as in the field of physics as modern and classical physics. So the modern chemistry is basically a chemistry of chemicals, and this is basically done by the two scientists, that is Jabir bin Hayyan and the Anthony Lavoisier. So these are two scientists who are considered as the father of chemistry. When if you are asked who is the father of modern chemistry, that the answer will be Anthony Lavoisier. But if you are asked as who is the father of chemistry or organic chemistry, so the answer will be the Jabir bin Hayyan, because Jabir bin Hayyan classified chemicals and prepared inorganic chemicals from the organic compounds, and Anthony Lavoisier discovered role of oxygen in the combustion and made a list of chemical element, noted conservation of mass in the chemical reaction. So that is difference between both of these person studies. So an element, how we can define an element. So the Robert Boyle, that was the English scientist in the 1661, defined element as certain primitive and simple or perfectly unmingled bodies. Unmingled means that are there, they have some specified structure which not being made of any other bodies. That is mean that they are pure, they are in pure form or of another, are the ingredients of which all those mixed bodies are immediately compounded and into which they are ultimately resolved. So this is the basically a previous definition of element, that we can conclude it as the element is simply formed of same type of atoms, because they are perfectly unmingled. They are not mixed with other elements, such as we can say that sulfur and oxygen. These are the two different atoms. Sulfur is an other atom, and oxygen is a different atom. So when these both combine, they form a sulfur dioxide or sulfur oxide. So they make a compound and a mixture substance. So element is basically a unmingled form of a unmingled body, because they are substitutely simply a single type of atom. If we divide sulfur in different and more smallest form, they will also be in the form of sulfur small atoms. So this is the basic definition of element, that is they are purely perfectly unmingled and pure form of something. So there is a Joseph Priestley, the first person to isolate elemental oxygen. This was the first scientist who extracted or isolate elemental oxygen. We know that the atmosphere contain molecular oxygen, not an elemental oxygen. So he was the first scientist who isolated elemental oxygen, that is simply in the form of oxygen element. That was the era of 1780 to 1790, achieved by using heat to decompose, and that was the process of mercury dioxide into mercury and oxygen. That is the process that is conducted previously by the scientist to obtain different substances such as mercury and oxygen, and he isolated the oxygen from this compound or substance. Then the era of Anthony Lavoisier came, and that is the era of 1780 to 1790. He observed that oxygen was the first element. So Priestley was the first scientist who isolated elemental oxygen, while the Lavoisier was the first scientist who observed oxygen was the element which was responsible for increase in mass of the combustion reaction. As much oxygen is available, there will be more combustion process, and you always saw that, and can be observed at a fireplaces. If the area is open and is surrounded by the air, more fire is exhausted, and the combustion reaction is more. So as much as oxygen available, there will be more combustion process. So Anthony Lavoisier observed that oxygen presence can be the cause of increase in the mass of combustion reaction, because only if a carbon is available, and that will not burn, because not much oxygen will be available. So combustion reaction will only proceed as if oxygen is available. Anthony Lavoisier developed a law of conservation of mass that is applied in all chemical reactions. During a chemical reaction, the mass of product will be equal to the mass of a reactant. So as a chemical equation is written as in, maybe I have written it in maybe lower, yeah. So here is a chemical equation, that is a mercury dioxide, and this is a mercury, and this is a molecular oxygen. So this is a reactant that is on the left side of the equation, and that is a product that on the right side of the equation. So these all things that are on the left side of the equation called as reactant, and that are on the right side are called as product. So in a chemical equation, the mass of product and the reactant remain equal or constant during a chemical reaction. That is the law of conservation of mass. So what are the difference between the chemistry and alchemy? And this is a simplest. Alchemy was mystic and have supernatural views of the reality. They considered that we can generate everything uh, from different substance, and it is simply as they basically use gold. So they have viewed that we can use silver and other metals as a substance or reactant to perform or to extract in the form of gold. So uh, here is a difference, simple difference between both of these. Okay. So chemistry is important because it that is about chemistry, not about the alchemy. So chemistry is important because it explains the world around you. It explains how food changes when you cook it and how it rolls. Basically, chemistry deal with the real chemical reactions that is occurred in the natural form or in the nature. So chemical reaction occur when you breathe, eat, or even setting down watching a TV. Chemistry was discovered by the Greek man called Leucippus in the 15th century. He came up with the idea that world was made up of atom or words. His students, Democritus, further refined the idea of atom and improved the theory so it can make more sense. So here is the idea about alchemy. They The alchemy, it is a form of chemistry that was studied in the Middle Ages, that is was in the BC, and which was concentrating about trying to change the normal metal into gold. So basically, they have view that we can change any metal into gold, and that is a mystic and super natural view or superlative form of thinking. It is the power to change or create thing in which seems mysterious or magical things, and because as we said that we cannot uh, change one thing into other, just in the form of matter to energy and energy to matter, because they were observing or thinking that they can change the chemical composition from one form to other. So it also involves the discovery of panacea and the proportion of the elixir of the immortality and the living forever. So it is simply an idea that uh, a human being can be created from something, because the idea is from to convert a normal material into gold means conversion of one thing into another thing. So Aristotle was another Greek philosopher who made a complete different theory than the one with atoms. So Aristotle was the first scientist we studied in the very slide, that he proposed that the matter is formed of earth, fire, and something. So he thought that all matter are made up of four elements, that is air, fire, water, and earth. By the physical manipulating the proportion of the element, matter can be changed from one another, because this was simply the idea of alchemy, and this is the transmutation form. So this is also known as the transmutation, and the main goal of it is to transfer ordinary metal into gold, because they were used mostly gold for their purification process, crystallization, because they use gold as a solvent. So they have perspective of transforming any metal into gold. So that's why they are called as alchemy, and that is the Middle Ages perspectives. Aristotle did not have a proof of this theory. However, because he was trusted and respected this idea, it has been 2000 year, even though they were wrong. And still until now, there are some people who believe in the alchemy, and the alchemists still exist. Some people think that the chemistry and alchemy are same, but they are different in many ways. First of all, alchemy relay a lot of spiritual connections, as they believe that we can convert one thing into another. So this is simply a spiritual idea, and uh, connection rely on the spiritual connections to the four element, and they are fire, water, earth, and air, while chemistry is a lot of more logical and factual and scientific based, because they study uh, all things under the experimental approach in the lab. So the third of all, chemistry is more famous than the alchemy, and it is a part of our modern society, and we are using it. Finally, chemistry makes more sense than the alchemy, and it does not risk our lives looking for the exile like alchemy. Chemistry and alchemy doesn't only have differences, they also have some similarities. First of all, chemistry and alchemy are similar in that
Guys, we have to wait because I think the teacher Elias have a problem with the connection. Okay, still in the class. Just wait. Okay.
is the internet problem.
Yeah.
So now,
Yeah, you can continue, teacher.
okay.
Sorry, guys.
So in chemistry and alchem, both use natural element as a both use natural elements which are now arranged on the periodic table, and the natural element from the nature and not being produced as a in the form of second element as isotopes are formed. So these are basically there is a similarity as a natural elements are used in both of these. Finally, back in the time of searches were against both of them because they thought that they use magic and proportion, which what they are totally against. So these are these were the differences between the alchem and the chemistry. And now it's just we have just few questions. Gold was used extensively thousands of years ago by the Egyptians. Which properties of gold are linked to this early use? They use uh, gold as a solvent. So what are the properties of gold that make it productive or uh, affirmative for the use of such processes that are maybe because golds are malleable and can be ductile, so these properties can be used to make most of the jewelry. And gold is in the form of soft form when it is heated, and it is a good conductor of electricity also, and unaffected by the air because it not react with the oxygen directly or easily, and can be used to make different form of alloys. So that is the answer for the first question, why gold is used extensively in the Middle Ages. And these are the properties of gold that make it can be used as a substance for the Egyptians jewelry. So what is the law of conservation of mass that is also studied in the previous trial? Also here mass is neither created nor destroyed in the mass of any one element as of that element that at the end of the reaction. If we using 10 gram of HGO, then there will be same amount of uh, mercury dioxide on the product side. That may be proportion of both of these. It can be 2 gram of oxygen or 8 gram of mercury, and it can be 5 gram or 5 gram both, and it may be in any proportion that make it equal to the used reactant. So the third question is, apply this law to calculate the mass of mercury oxide, which would be decomposed to produce 2 gram of liquid mercury and 0.16 gram of oxygen gas. So we have to apply this law on this question. So here is a balanced chemical equation, and how much quantity of we have in the question. Here is 2 gram of liquid mercury, that is at the right side on the product side, and this is a mercury, and this is a molecular oxygen. So we have 2 gram of mercury and 0.16 gram of oxygen. And as we said in our law of conservation of mass, both will be combined and form a equal product of a reactant. So that will be 2.16 gram of HGO. So the reactant mass will be 2.16 gram. So okay, that is by the another scientist, and from this, as letter, it can be first letter or two letter of their name, as in the form of first letter of Latin names PB, that is Columbus, the P from first and B from the middle, and copper, Cu from the Cyprus, Latin word that is caprum. First letter of element in another language, tungsten, that is written as W, capital W, and German Wolfram. The element or name or symbol can be from the name of the scientist or from the uh, anything that from where it discovered. And mercury, the Greek word hygor, agarus, meaning liquid silver. So that is how we can symbolize the element. Now, Joel Dalton discovered symbol for the element and derived symbol for the element. In 1805, he proposed that matter was proposed of atom and backed this up with the experimental finding. So John Dalton was the scientist who symbolized the element and also composed a theory of atomic theory, that is all thing or all matter are composed of atoms. Here was the key ideas of the Dalton about the atomic theory. All matter consist of individual atoms. Atom of particular element are identical element have unique weight. Atoms are neither created or destroyed in the reaction. Compound are formed from the combustion of the atom of two or more element. The properties and kind of element is fixed in the given proportion, as we said in the our last equation. So atom combine in a simple numerical ratio. The numerical ratio may be as 2:1, 2:2, or 2:3. That is the ratio of 2:1. So it is total 3, and this is the proportion of atoms. Atoms combine in simple numerical ratio. The most stable compound of two elements contain the atom in 1:1 ratio. So if they are containing 1:1, that will be the simplest and stable form of compound. Dalton key idea gave hydrogen the relative atomic weight 1 unit and compared other element to this. So this is a complete theory how we can compare one element with the other. Firstly, by the Dalton, hydrogen was used as a standard element to compare one element mass with the other, and then now we use carbon as a standard element. So here are some element and their compound formulas and their names. And now the theory of periodic table came. Can we think some element with the similar properties? How about the different properties? So this is the table of element or compound from the Middle Ages. There is not a modern chemistry compounds. So now the Berzelius was the scientist who gave the element their various symbol and synthesized many compounds, isolated and purified many of the common element, calculated accurate relative. Berzelius was the first scientist who calculated relative atomic masses of the elements. Then came the Dmitry Mendeleev, who created a most stable form of the periodic table from the vast amount of experimental data available from the previous chemist. He determined chemical properties of the element vary periodically with the increasing atomic mass. So Mendeleev was the scientist who performed or made a periodic table on the basis of chemical properties of element, while the other was the previous scientist basically making the periodic table on the basis of their atomic masses, that was relative atomic masses. So new elements are discovered in the Mendeleev periodic tables, and some spaces were left because he think that there are some element that has to be discovered, and their place will be come in the that place. So that is the periodic table that is discovered or made by the Mendeleev. Mendeleev's table was not complete, but it allowed him to predict properties of the undiscovered element, including color, density, and boiling point, etc. So he made this table on the basis of chemical properties, so he can also observe or can think about the next element that are being placed on the other form. So now we will discuss simply about the scientists who made simplest discoveries. So early Greek scientist, that was Democritus, he proposed that all matter is made up of small invisible particle that is called as atmos, and now it is called as atom. Aristotle, matter is continuous and not made up of smaller particles. So the smallest form of matter is atom. Then covered a relation between the pressure and water, and it is PV equal to constant, some constant, that is K. Then Antony Lavoisier, that came with the idea matter cannot be created or destroyed, and the proportion of masses remain equal in both sides, on the product and the reactant side. Joseph Proust found that a given compound always contain exactly the same proportion of element by mass. By mass means as we can consider H2O. So if we considering a large amount of water or simply one molecule of water, both will contain same proportion of element as in a compound. To form a compound of or molecule of water, we have to take 2 atom of hydrogen and 1 atom of oxygen. So the proportion will be remain same in all forms. Then the idea of John Dalton, the relation of masses of the element in a compound can always be reduced to small whole number. That is can be written as 18.000 something, and he proposed that the masses can be written as a whole number. If we are having a mass of some element in 17.999 form. So we can reduce and make it whole number as 18. So the law of multiple proportion is deducted by the John Dalton. John Dalton gave the atomic theory, and that is all matter composed of tiny particles, that is called atom. The atom of the element are always identical, while the atoms of different element atom combine small hole ratios. When when a different atoms combine, they form a compound. So the atoms themselves do not change. So the properties of atoms in a chemical reaction never change because they contain similar properties as the other. So Dalton proposed that the billiard ball model of atom, a rounded form of atom at the center of the uh, atom was nucleus, and electrons revolve around them. So that is the simplest form of atom that is proposed by the Dalton. Then Jos Gray Lucas measured the volume of gases that reacted with one another to develop the law of combined volume of the gases. So now came the Amadeo Avogadro, who proposed that the same temperature and the pressure equal volume of the gas contain the same number of particles. In a container, if we have same temperature, equal volume of both container, and if we apply a same temperature and pressure on both, then we can say that we have same number of particle in both containers. That is law given by the Avogadro. And then J.J. Thomson came and he produced experiment that produced a cathode rays. So cathode rays are discovered by the J.J. Thomson, which was deflected by the negative electric field. Thus, the ray must be made up of negative particles. He proposed that if a cathode ray is deflected by the negative electric field, that is must that the rays are containing a negative particle or negative charge. So since the atom are neutral, they must always have positive area. Theory that is given by the J.J. Thomson, that is uh, observed as the positive negative charges to neutralize the atom. That is a plum pudding theory. Then also proton were found to be 1836 heavier than electron, so that is also positive one. And the charge of experiment of Robert oil drop experiment to determine the magnitude of electron charge. That is the process where we can conduct to check how many negative percentage of charges an electron contain, and that is a whole experiment. Chadwick was the first scientist who discovered high energy particle with no charge and the same mass as a proton, that was a neutron, and that came from the experiment of Rutherford, and that was the colleague of Rutherford. Then Henry Becquerel, that was considered as the discoverer of radioactivity process, accidentally discovered by the Henry Becquerel, and that was the alpha particle that contain +2 charge and also contain beta particle and gamma radiations in the experiment that in the radioactive process. Then Rutherford came and he proposed the test to test the Thomson theory of plum pudding, and he conduct experiment and found the structure of atom, and he proposed that the most of the area of volume without any space, and some area is have dense particle, and that is called as proton. So then Robert Benson found that when heated, different element produce different color in the flame. Bohr gave the rounded structure of atom, orbital structure of the nucleus, and it was the against the Rutherford model. And the same Arnold Sommerfeld expanded the Bohr model, and electron travel in orbit, but orbitals are not the same shape. That is basically about the shapes of the orbital. This lead to the electron cloud model of the atom, and the electron cloud model is here. That is a simply cloud model of the electron. Then another scientist, Pauli, predict that the electrons spin while orbiting the nucleus. That is the spin around their own axis. Pauli-O'Clain principle is basically used to put the number of electron on the orbitals. And the Broglie the Sogrinder wave equation, they gave that the electron that revolve around the nucleus may be in the form of a wave structure. Then Heisenberg came, and that experiment is called as uncertainty principle, and that is basically determine the position and momentum of rotating or orbital electron. Then modern view of the atoms are tiny nucleus surrounded by the electron, that is called as cloud, that we saw in the last slide, and the nucleus account for all of the masses the atom is, and the arrangement of the electron cause the that performed or that can be occurred, that is basically the by the cause of electron. So that is the topic today we discussed. If you have any question, you can ask me. These all are the history, or we just discussed simply and the simple ideas that is given by the different scientists, but we have to study all of them in a detail in the chapter form. Maybe that we can discuss in another lecture in the detail. If you have any question about the history of the chemistry, you can ask.
Guys, it's clear because the class is going to be done now. It's clear. If you have some questions, you can take your phone, your phone, and ask to the teacher. Everything is clear. Elias. Okay. Thank you so much, Elias. It's excellent topics. Guys, thank you so much for being here. I want to see you in the next class. Okay. Have a wonderful day to all of you. Thank you.
Bye, teacher.
Bye.
Okay, thank you. Bye.
Bye.